When I solve an equation, if I can't solve 2 plus 3 because there's no equation there. Okay, Grant? David? Can't solve it. I can simplify it. I can evaluate, but I can't solve it because that's not what solve means. To solve, I need an equation. X plus 3 equals 7. Okay? I'm going to tell you x equals 3. Did I solve it correctly? Lucas, is that solved correctly? Because if you know what this word means, all the rest of your math is going to be way easier. Jake, did I solve that correctly? Why not? What?
No, because 3 plus 3 is not 7.
Excellent. 3 plus 3 is not 7. You put this back in here, you're trying to find a number that you add to 3, and you get 7. So solve, Grant, because I don't think you really understand what the 6x minus y equals 1 means. Solve means to find, and you should write this down, the number or numbers that make the sentence true. Now, there is a process that we can learn to try to figure out what number was added to 3. Okay, Caitlin? Guys, this is critical. There's a process there. I mean, can you just look at that and tell me what the answer is? Kathleen, what's the answer? 4. 4 makes it true, right? But what if they're not nice numbers? Half the time, no. 99% of the time, they're never nice numbers. So we have to have a process. So here, I want to find numbers that make that sentence true. But guess what? I have pairs of numbers. I have x's and I have y's. So Grant, what would you like to put in for x? I could create a little table here. I only want the pairs that make that true. What if x is 0? What would make this true then? What y value? 6 times 0 minus y equals 1. Well, what's 6 times 0? 0. So it says the opposite of some number is 1. If you put it in English, it makes more sense. Opposite of what number gives you a positive 1? Negative 1. If I put this ordered pair into this equation, I should get a true sentence. What if I let x be 1? Oh, there's something special about this one. If the x value is 0, what's this called? The y-intercept. It's special. When one of those are 0, one of those values is 0, then it's very special. Okay, what if x is 1? Then what do we get? We get 6 times 1 minus 1 equals 1. What's 6 times 1? 6. Whoops, I forgot my y. So it's 6 minus something equals 1. Can you tell me what the something is without solving it? 5. Okay, Grant? So this is 5. How many ordered pairs are there that make that true? Is there any limit? Could I put a half in? Could I put negative 1 in? There's a whole bunch of them. Now, in a plane, this is a plane, a flat surface, there are an infinite number of points. Do all of these points work? Does the origin work? Does 0, 0 make that true? Is 6 times 0 minus 0 equal to 1? Is that true? No. Okay? That is not true. So only certain ordered pairs make that true. And it turns out that these ordered pairs will lie on a line. And when we get to quadratic, we're going to have x squares in them. And now it's not going to be a line anymore. And then 1 is going to be 5. So it's going to be those sets of ordered pairs. My board's a little off, sorry. That's it. So that's what I'm trying to do. I'm trying to find a way to list all these ordered pairs. There's too many of them. So I have to make a picture. That's what a graph is. Did you know that? A graph is just a picture of all the ordered pairs that make that sentence true. I can't list them all. It's impossible. Okay, so now I'm going to go back to where I was. So what I want to do to graph this is I want to solve for y. I will come back and talk about solutions over and over again. And what does it mean? Because once I know what it means, this isn't that hard. Okay, do you remember slope-intercept form? Y equals mx plus b. This should be review, but maybe some of you didn't get it all the first time. So guess what I have to do here? I have to solve for y. And we do the same thing every time. I want to isolate the y. The y is not alone. -1 is accompanying y. So I want to get rid of whatever's being added to y. We always undo the adding first. So how would I get rid of that, Kathleen? How would I get rid of a positive 6x? I want it to go away. Minus 6x. Some of you want to drop the x. You think I'm being nitpicky. I'm not being nitpicky. Grant, -6 and -6x are not the same things. They're not. I know a lot of people who think ponies are just small horses. They are not the same thing. They're different kinds of animals. So you have to be nitpicky about this. You can't take 6 from 6x. Okay, so I check that's 0. What comes down still? This is 0. What follows a 0? Minus. I'm being nitpicky about that. It's not right without the minus. Y equals, can you add a 1 and a 6x? Emma? No, you can't do it. You can't even subtract them. You just write it like this. In other words, you can't simplify them. Okay? Kathleen, you got this part? Then what do? I don't want a -1y. I want it positive. No, this is, you have to look at the operation. This is multiplying. How would I get rid of, undo multiplying? I will divide by a -1. You must do this to every member of this family here. I can do more than one example, but y is equal to what? -1. What's going to happen here? Plus 6x. Now, it's not in the right order. So it's okay if you can remember which is which. This is the slope. I'll circle the slope. The slope is a number. It's a measurement of steepness. And what's the y-intercept? Grant? What's b? Where do I begin? If you don't get it, then you got to really focus and pay attention. This is the y-intercept. This is where we begin, -1. Okay, I'm going to take a graph up here. It'll take me a second because I got to slide it all the way down the board. I don't know why it does that, but it does. I don't like that. But I'm not complaining because I got a free graph. Okay, there we go. And where do we begin on our graphing? David, where do I begin? It says begin where? At? Okay, where is that -1 located? There's a whole bunch of points. Great, it's on the y-axis. Now, do you know how to do the slope? It's a 6. It's 6 over what number? Okay, so David, how do we do that? Up 6. 1, 2, 3, 4, 5, 6. And I'm going to go to the right. 1. And there it is. You really should draw the arrows on the end because lines do go forever. And in 2 years, you'll be in geometry. No, next year you'll be in geometry. In which case, then you're going to get real picky about notation. Okay? Do you need me? Oh, Lala wanted me to do number 10. Oh, that one's not a very nice one. It's x minus y equals 1.
It's like fading on like mine, so I can't tell if it's a negative or...
It is. Then you might have to go to the book. It's just the way I take the pictures. When I blow it up to be bigger, it ends up not looking very nice. It's all I can do. Unless I would take a picture of my cell phone. I didn't try that. Okay, so I want to solve for y. So what do I have to get rid of? Lalo, what do I have to get rid of?
Y or x.
X. So minus x. And I know, Nick, you want to add the 1 and the minus x, but you can't do it. They're not the same. Those are. So it's minus y equals 1 minus x. Be like if I wanted to count up all the computers that they sell at Best Buy. There are a lot of different kinds of PCs, or TVs. How about TVs? I want a 47-inch TV. They got Toshiba, Samsung. They have a bunch of them. Put a Toshiba and a Samsung. They're not the same machine, and you can't count them together. They're not the same. You can't add x's and y's. You can't add numbers and x's. Okay, now where'd you get stuck now? What do you have to do next? I don't like that negative. Did you forget the negative that was here? Most people forget it. So I'm going to divide by what? A negative 1. And I'm going to get y equals negative 1 plus x. Or y equals x plus a negative 1, which is x minus 1. They're all the same things. Do you need me to graph it, or you know how to graph it? Mm-hmm. Did you get the right answers? You have to check your work. I have all the answers up. I'll go back. Do you know how to graph this? What's the slope? Cole, what's the slope here? It's the number in front of x. For some reason, we don't write that number. Here's another way to do it. How many x's do you see? 1. Where do we begin? No. This is where we begin at negative 1. Do you remember that?
Then you would just add it.
So, Grant, you should be doing this problem because you haven't done this. You should do it. And then we're going to graph it. So we're going to start it. We're going to start at negative 1, right there. And we're going to count equal, over, and up. That's the 45-degree angle. I'm going to go over 1, up 1. Over 1, up 1. I do over, up, but you guys can go up 1, and over. I don't care. And there it is. Okay, so you need graphs with these. Now, I couldn't do a graph on Schoology. I don't know how to put them in. So, you're going to have a graph on that quiz. So, I'm going to put the answers back up. You have the answers to the odds. But there's your work. There's your answers for the evens. So, I've done, did I do 4? I think I did 4. And I did 10, so 6 and 8. And I just did it is what I did. Whoopsie.